Okay, T0C, RF hazards, radiation exposure, proximity to antenna, recognize safe power levels, and exposure to others. And hopefully you have that other sheet that I sent to Joe after last session that has, it's called radio frequency exposure limits. So if you can get that in front of you, and here's a little part of it right here that I scanned in right down here. What type of radiation are VHF and UHF radio signals? They are non-ionizing radiation. Now what that means is they don't break down the material inside the cells of your body. They don't ionize chemicals. Okay. If you get up into the X-ray and gamma ray part of the electromagnetic spectrum, that's ionizing radiation, and that can cause damage to the chemicals in your body. But VHF and UHF radio signals are non-ionizing radiation. Okay, here are the power thresholds for routine evaluations of amateur radio stations. And the main reason I put this in here was because I wanted you to see how much the power varies for these various power thresholds based on the frequency. So here we're in the 160 meter band, and we can go up to 500 watts of power without having to do any kind of evaluation on radiation exposure. And same for the 80, 75, and 40 meter bands. We can go up to 500 watts before we have to do any kind of evaluation. As we go higher, here at 30 meters, 425 watts, at 20 meters, 225 watts, at 17 meters, 125 watts, and on up until we get to the 10 meter band here. 50 watts is enough that we need to evaluate the power thresholds for human exposure. Same thing here in the VHF. 6 meters, 2 meters, and 1.25 meters, again 50 watts is where we need to start evaluating. And then as we go above that in frequency at 70 centimeters, 33 centimeters, and so on, then the allowable power level goes up again, okay, before we have to start doing the evaluation. Now, I did not used to give you this radio frequency exposure limits paper. I didn't used to use that in class. One reason I started to do it was, first of all, it helps to explain some of the following questions that we have here. But also, when you sign the application form, your 605 application form, you certify that you are familiar with these limits. So I thought it might be a friendly gesture for you to have it so that you could honestly certify that you're familiar with it. Okay, which of the following frequencies has the lowest maximum permissible exposure limit? Of the ones they give you, it's 50 megahertz. 50 megahertz. Okay. What's the maximum power level that an amateur station may use at frequencies above 30 megahertz before an RF exposure evaluation is required? Now you remember 30 megahertz is, let's go back, 30 megahertz is going to be the top of the 10 meter band roughly, okay? So right in here is above 30 megahertz, isn't it? And we're talking about the 50 watts. What factors affect the RF exposure of people near an amateur station antenna? The frequency and the power level of the RF field, the distance from the antenna to a person, and the radiation pattern of the antenna. Remember, we create gain, don't we, when we build that pattern that puts more power one direction than another. So a person standing beside a beam antenna receives less radiation than a person standing in front of it. All of these choices are correct. Okay, so frequency and power level, distance from the antenna to the person, and the radiation pattern of the antenna. How much does this stuff really matter? It can matter quite a bit. I have a friend who I recommended a radio for him to buy, and he bought a more powerful one because the dealer made him a good deal on it. And he ended up putting, in his small pickup, he put a 75 watt 2 meter radio. And he had a gain antenna on his top of his truck. And so let's say it had a gain antenna that doubled the effective radiative power. And I said to him, you've got a problem there. Only transmit at high power while you're sitting in the truck. Don't transmit at high power if you're standing outside or if anybody else is standing near the truck outside, because that would have increased its power level to where it exceeded the exposure limits. So you may think about this happening only with high-powered radios, but it can happen with something as simple as an installation in a car or truck, especially if you're running more than a 50-watt radio. Okay, why do the exposure limits vary with frequency? The human body absorbs more RF energy at some frequencies than at others, and we saw that in the table from the exposure limits there. Which of the following is an acceptable method to determine that your station complies with FCC RF exposure regulations? You can do calculations based on the FCC Bulletin 65. You can do calculations based on computer modeling, or you can do measurements of field strength using calibrated equipment. All of these choices are correct. And if you're running high power, you should do these things to make sure that you're not endangering yourself or your family or people who live on adjacent properties. If you keep your power down, then it really isn't an issue. What could happen if a person accidentally touched your antenna while you were transmitting? They might receive a painful RF burn. Which of the following actions might amateur operators take to prevent exposure of RF radiation in excess of FCC supplied limits? One thing you can do is relocate an antenna. And for example, let's suppose you have a beam antenna and maybe you have a restrictive covenant in your area that doesn't let you put anything any higher than 20 feet. So you have this beam antenna at 20 feet. That could cause quite a bit of radiation to people near you. You could actually reduce the radiation exposure by getting that antenna up to 60 feet, which would also improve your performance a whole lot. Excuse me. How can you make sure your station stays in compliance with RF safety regulations? By reevaluating the station whenever an item of equipment is changed. So if you put in a power amplifier, increase your power, reevaluate your compliance with the RF safety regulations. Why is duty cycle one of the factors used to determine safe RF radiation exposure levels? It affects the average exposure of people to radiation. The heating effect that you get from this is based on the average exposure. Let's take a look at duty cycles down here. Here's a 10% duty cycle. The power is on for 1 second, off for 9 seconds. On for 1 second, off for 9 seconds, and so on. That's a 10% duty cycle. Okay? Here's a 50% duty cycle. Power is on for 5 seconds, off for 5 seconds. On for 5 seconds, off for 5 seconds. Okay? So you can see here that the person is going to have 5 times as much exposure with this duty cycle as they are with this duty cycle. Okay? Here's a 90% duty cycle. It's on for 9 seconds, off for 10 seconds. On for 9 seconds, off for 10 seconds. So here you would have 9 times the exposure that you would have with the 10% duty cycle. Okay? And that also pretty well answers this question of what does duty cycle mean. It's the ratio of on time to off time of a transmitted signal. Okay? So it affects the average exposure